In this video, I want to go through the ChangeMaker lab. So what I did was in my IDE, I created the class, I created a main, and then I started adding the methods. So we're going to start with number 2, complete the method, public static int, simple search. It takes in an integer array and a value to search for, and that performs a linear search. It's also called a sequential search on the array parameter, and returns the index of the first occurrence. Now it's important to recognize that it's the first occurrence of the value parameter, or it returns 1 if the value doesn't exist in nums. So given this sample with this array, if we're looking for the value 7, 7 is at index 2. So let's begin to code this search. So I do know that I need to loop through the array, and I'm going to test every single value that I come across. If I find one, I'm simply going to return the index right when I find it. If the loop were to finish and I did not find the key, or the value as it's called, then I will just simply return -1. So let me handle that first. I am going to write a loop, but if the loop finishes and I don't find it, I'm going to return a -1. Up here, however, I'm going to write a traditional for loop, and I'm going to go through all the values in nums. Let me make that error fixed. So this is standard loop. I start at 0. I increments up till it reaches the length, but isn't allowed to equal the length because the length is not a valid index. And I'm going to look at each value. Square bracket I, that'll get me the element at index I, and I'm going to see if that equals the value. And if it equals the value, then I know that the value I'm looking for is at index I, so I can return index I. And let's test this up here. Put it in a print statement. So simple search. We'll pass in a new integer array. Add some values. And then let's go ahead and add one of them twice, just to prove that if we're looking for 8, it should return the first occurrence, which is at index 2. And we'll run this to make sure that our code is working. Oh, so what I did was I didn't account for all of the methods that I hadn't finished writing. So let me fix that by marking those out. We'll come into those later. All right, we'll try again. And it does return the first occurrence, which is at index 2. Now let's look at the next problem, number 3. Number 3, complete the method public static void square board, taken an integer n that prints an n by n board with hashtags or pound symbols, whatever you want to call it, characters at every position. So here's an example. If we pass in a 2, then we have a 2 by 2 grid of pound symbols. Now it's important to note that there's a space after each one. So it's a pound symbol plus a space, pound symbol plus a space. Okay, so I've got my header for number 3 over here. It is good to look at the headers just to make sure you understand what's in them. Returning void means I'm not going to return a value. And in fact, since I'm just printing in this method, then I have no reason to have any return statement at all. So in order to get a rows and columns kind of an output, this really needs 2 loops. This is a nested loop problem. So anytime you have like a rows and columns, you need 1 loop for the rows and 1 loop for the columns. So I'm going to use a standard loop. R is going to be my loop variable because that's going to help me remember that this has to do with rows. And I want n number of rows. So if I start at 0 and go up to but exclude n, then I'll know that this loop will run exactly n times. And inside, I'm going to use the letter C for my loop variable because C will help me remember it's for the columns. And of course, I want to have the same number of rows as I do columns, so both of these loops will terminate at n. Now in the middle loop, this is for printing out exactly 1 row. And so I'm going to use print instead of print line, and I'm going to print a pound sign plus a space. Now, if I run this the way it is, I won't have any new lines. So I have to let this print. Let's say that it was a 10 by 10 grid. Well, I want this inner loop statement to run 10 times, but then I would have to follow that up with a new line character. So right after the inner for loop, you do want to print an empty line. Basically, this gives us our new line character. So let's call this in our main. And there's no reason to put this in a print statement because you can't print a void method call. So instead, we're going to call square board. I'm going to pass in a 4. We should see a 4 by 4 grid. And there's our 4 by 4 square board. I'm going to go back and look at number 4. Number 4 is similar to number 3, but in this case, we want to print a checkerboard. So if you look at the one at the top, we've got, pound space, pound space, pound space. But on the second row, we have, we put the space first and then the pound, space and then pound. So we have to alternate what kind of rows we want each time. So this can be done very similar to number 3. And in fact, I'm going to steal some code and just refactor it. So I'm going to take my loop here that I created in square board, put it in here. Now, this works for the first line and the third line. If we look at the output, it works for the first line and the third line and the fifth line and the seventh, but it's not going to work for the alternating rows. So I have to provide an alternative for every other row. So I'm going to put this in an if-else statement. I'm going to come back to that. I know I need a new line at the end regardless. So let me format this a bit. Okay, so I'm going to use my loop variable. If you notice here, r would be equal to 1 on the first row. I'm sorry, r would be equal to 0 on the first row, and r would be equal to 2 on the third row. So you can see every time r is a multiple of 2, we would want to print the pound and then the space. So I'm going to test r to see if it's a multiple of 2. And if it is, I'm going to print this the way it is right here. And otherwise, I'm going to change this up so that the space prints first. So the inner loops are going to alternate between the pound space and one that does space pound. And regardless of which inner loop runs, we're still going to print a new line at the end. So let's call this one checkerboard. I'll pass in a 4 so we can see boards. And it's this block right here, and it looks fine. So I'm going to change these to 2 just to reduce the output they have. All right, let's look at number 5. Number 5, complete the method public static double convert temp. So we're going to pass in a double for the temperature and a Boolean for if it's Fahrenheit. And this will perform a Celsius to Fahrenheit conversion or vice versa when called. The parameter is F will be supplied as true if temp is a Fahrenheit number. Well, the first thing we have to do is figure out what the formula is for conversion between Celsius and Fahrenheit. Unfortunately, we have the nice internet for that. So how can I write this? There we go, F to C formula. That's even easier than figuring out how to spell Fahrenheit. Well, the formula is given right here. It is, you take, if it's Fahrenheit, you subtract 32 and you multiply by 5 divided by 9. So I am going to come over here to my code and So actually, I'm going to say if is Fahrenheit, and I'm going to handle this situation first, and then I'll come back and handle the Celsius situation. All right, so our formula is we would take our Fahrenheit value, subtract 32, and then multiply by 5 divided by 9. Let me just double check that one more time. 5 divided by 9, that's correct. Of course, that's a mathematical formula, and we're going to have to convert it to Java. And because, well, this returns a double, so all I have to do is return the result of a formula. So I'm going to take my temperature, subtract 32, and we do need parentheses because this is subtraction, and the subtraction has to occur before I multiply it. So multiply by 5.0 divided by 9. The reason why I'm using 5.0 is because I need it to act as a double. I don't want integer division here. You can put 9.0 if you want here. And that should give us the answer for Fahrenheit. Now the reverse, I just have to undo this formula. I would take Celsius, I would multiply it by the inverse of that fraction, and then I would add 32, and that should equal Fahrenheit. So write it in Java. So we take the temp, we multiply it by the 9.0 divided by 5.0, and then add 32. So we're going to check our formula, or we're going to check our answer in our calculations here. So over here, if we put in a value of 100, we should get 37.7778. Convert temp, 100, and this is in Fahrenheit, so true. And we'll also check to see Fahrenheit, or Celsius to Fahrenheit. So we'll put false here. All right, so I'm going to put here also what we think the answer should be. 37.778, something like that. And for this one, we would choose Celsius to Fahrenheit, and I wanted to test 75. So we should get 167 back. 167. Let's see how we did. So we did get the answers that we expected, and we tested it with the Google converter. Okay. Now we're going to look at number 7. I believe 6 was a riddle. Number 7, this is the is Armstrong method. Complete the method, public static Boolean is Armstrong, and takes in a number. This returns true if the supplied number is an Armstrong number. An Armstrong number is a number for which the sum of the cubes of its digits is equal to the number itself. Modulus and integer division will help. Please don't use strings. If you get stuck, there's an algorithm in the lab folder. So let's look at the example that they gave. So 371 apparently is an Armstrong number. So how did they derive that? They took the digit 3, they cubed it, they added that to the digit 7, which is cubed, and the digit 1 that's cubed, and it does happen to equal 371. So number 7. You have to have a way to peel off the digits, and once you have the digits, you can cube them and sum them. So I do know that I'm going to need a sum, because that's what I'm going to be adding up. And then I need a value that is going to, it's going to be my working number. So this is one I'm going to to change what its value is. N will take on the value of num, but each time I'm going to strip off a digit, so n has to be different than num. And in the end, I will write a loop before the return statement, but in the end, if the sum is equal to the original number, then it is an Armstrong number. So here in my loop, I'm going to run this loop while n is still greater than 0. And inside, I'm going to get one digit. And I'm going to get the ones digit. So if our number is 371, I'm literally going to get the 1. So I'm going to take n, and I'm going to mod by the base. Since we're in base 10 numbers, if I divided the number by 10 and took the remainder, I'd get the ones digit. And then I'm going to cube that and add it to the sum. So we'll use math.pow. And we're going to take the digit and we're going to cube it. And then before we start the loop again, I'm going to peel off that digit so that n is reduced. So n equals n divided by 10. And just so you can see how this is working, let me just do a few printouts. So I'm going to print the digit. Whoops, I didn't mean to do that. Print the digit. And then I'm also going to print, let me go back, print n. Just so you can see what happens to n as we go. All right, we're going to call this with 371. And since it returns a Boolean, we'll go ahead and put it in a print statement. So we're going to pass in 371. And just to make sure that it does return false, for a non-Armstrong number, 370 shouldn't really be an Armstrong number. Okay, so let's run this. And we'll bring up the method so you can see them side by side. Okay, so for the first one, we're looking at this. You can see that the first time through the loop, the digit I pulled off was the 1, and that n has the value of 371. But remember, before we start the loop again, I divide by 10, so now n becomes 37, and the last digit is 7. And then the loop will iterate one more time, but not until I pulled off the 7. Okay, so the loop stops when n equals 0. So we did get a true for this one, but I'm not expecting a true for this last one. So maybe it's an Armstrong number too. Let's try a different one. So 55, that should not be an Armstrong number. Okay, so we did get a false. All right, who knows? I randomly picked a second Armstrong number, but I think it is an Armstrong number. Okay, so we did get the answer that we're expecting, and I'm going to remove these additional print statements so they don't show up in our printout anymore. Let's look at number 8. Number 8 says complete the method public static Boolean contains. We pass in an integer array A and an integer array B. This returns true if the sequence of elements in B appear anywhere in A. They must appear consecutively and in the same order. They must be done without using string or string methods. So we will need a nested loop for this, and we're going to go to the whiteboard to look at an example. It's a good idea to go to a whiteboard or scratch paper so you can see how things fit together. So here's array A and array B. I know I'm going to do this with a nested loop. So I is going to start here at 0 and work its way that way. That'll be my outer loop. My inner loop will be J, and it'll work its way through array B. Now, it's also nice to have a third value K, third variable K, which is going to be set equal to I, and it's going to be what loops through A. So I gives us the starting position for k, but it's really k that moves through. So if our inner loop looks at this one, and let's say I is equal to 2, k would start here and check that one. Then we would check this against this and this against this. And so k is going to work its way through these values here, these three values here. Okay. Now, if you look at array A, you'll see you don't want to go all the way to the end. For instance, if I started k right here, k would not be able to go 2 additional positions. We would run out of space and we go out of bounds. So we want to limit the first outer loop. So let's look at how we might write the control statement. So our control statement in the first outer loop is going to say I less than some value. So how are we going to get that value? So if we take the length of A, which is 5, and then subtract the length of B, which is 3, what do we get? And what I'm really looking for is the first values that I want to exclude. So I is going to go, it's okay if I is at this position or this position or this position, but I don't really want to go to these starting positions for K. That won't work. So I really want whatever this value is here to go there, okay? And this is index 3. So over here in our equation, we would have to add one additional 1 so that we get at the right index to stop at. So right here, it'll be a dot length minus b dot length, add one back. And that's going to be our control expression for the first loop. So let's get started on the code. So I know I need an outer loop, and the limit on that outer loop is a dot length minus b dot length plus 1. And then the inner loop, I'll use variable j, and it's just going to have to stop when it reaches the end of b. So I also need to create variable k. Remember, k is the one that's going to increment and basically keep pace with b. And so k will start at position I. And when I use it in the inner loop, I will increment it after each use. So we will have an if statement in here, but let's do a little bit of planning ahead. So I want to know if all the values in B appear in A starting at index K. And I need all of them to appear. And if I find that any one of them, single one of them doesn't appear, then it's not present and I need to keep looking. So I'm going to create a variable called all present. I'm going to set it to true. I'm going to assume that they're all present, and then I'm going to look for a counterexample. So A at index K, if it does not equal B at index J, whoops, jump ahead here. If it doesn't equal B at index J, then I know that they are not all present, and I can just set that equal to false. And of course, K will increment inside the inner loop. But once the inner loop finishes, I will know for certain if all of them are present, so I can test that. So if all are present, then I can return true that they have been found. If this outer loop finishes and I've checked everything I could possibly check, then I know that the sequence of B does not appear in A, so we can return false. So let us code some test cases. I've already written the test cases in main, and those are the two that were given to us. So let's run this. I'll put the code back up while it runs. And the first one should be true and the second one should be false.